Hello friends, welcome to Basic Electrical YouTube channel. So in previous lecture we learned the construction details of an alternator, and we found that two types of alternators are there. One is called salient pole type alternator and another one is non-salient pole type alternator. So along with that, this question is also very important. Okay, so this is class number 9. So this question regularly asked in old scheme. Okay, but in this scheme, 21ELE13 scheme, this topic is not clearly specified. Okay, but overall, by seeing the syllabus, so it is indirectly it is required. Okay, so for general knowledge purpose, this topic is very important. Once they ask for construction means, you must know why they are going for those type of construction, why they are going for rotating field construction only. So for that you must know the reason. That's why I have taken additional lecture for this particular model, because exactly not specified in the syllabus. Okay, but it is required to understand construction of alternator. So before constructing of alternator, I could have explained this point, but later I noticed, so I am explaining after construction. So please cooperate. Okay, so what is the question? What are the advantages? List out the advantages of rotating field over rotating armature. Rotating field over rotating armature. Okay friends, list out the advantages of rotating field over rotating armature. We are using this type of construction only in generating higher voltages. So let me give clarity, much more clarity. So let me take, this is a stator. Okay, in previous lecture only I told, okay, little bit basics. So to understand all these points, this explanation is required. So this outer two circles are stator and inner circle is rotor. Okay, so this one is stator. Okay, this one is stator, and this one will be rotor. See, the rotor is mounted on the shaft. See, there are two windings. One is called field winding. One is called field winding, and another one is armature winding. Another one is armature winding. So generally, the armature winding will have so many conductors. With respect to field winding, field conductors are very less compared to armature. So let me consider there are 1000 conductors in armature winding and 100 conductors in field winding. Instead of that, I am going to take 1000 conductor means you will get some amount, some certain kg. Let me take 50 kg. Assume, this is only for assumption, to understand all those points whatever I written. For that we need this one. Okay, some assumption. Armature winding, the weight of armature winding is 50 kg. And now the weight of the field winding is, let me take 5 kg. Okay, so this is the difference will be there. Armature winding weight is very high compared to field winding weight. See, now 50 kg, this many lot of conductors will be there, where I can accommodate easily lot of conductor in the rotor or in the stator, where lot of space is available in the stator. So that's why I am placing this armature winding in the stator, because lot of conductors are there, weight is also more. Okay, so that it is, suppose if I place this 50 kg in the rotor, what happened? Rotor mounted on the shaft, the total weight on the shaft get increases. Okay, that will affect rotation. Then it is having high moment of inertia. Okay, but from mechanical point of view, it is always better to rotate low moment of inertia system. So if I place field winding in the rotor, what is the weight of field winding? 5 kg weight on the rotor, not much effect. Okay, we can eat rotor will run smoothly. Okay, got it? Because the total weight, the net weight on the shaft is very less. so that rotor runs smoothly. It cooperates with turbine rotation effectively. But if I place larger weight of winding on the rotor, then this rotor refuses to rotate due to high moment of inertia. So because of that, so I can place this 5 kg here also, outside also, but lot of space getting wasted here. So that's why I am using more number of conductors I am putting in the stator. Okay, so this armature winding, okay, this is called armature winding. So armature winding I mounted on the stator, then it becomes stationary armature. Okay, see, because of this large conductors, the armature will going to induce a voltage up to 11 kilovolts. Okay, whenever the rotor flux cut the stationary conductors, high voltage is generated. Okay, so that is the first advantage I have written here. So next, rotor field winding. Okay, in field windings is placed in the rotor. Then it becomes what? Rotating field. Okay, then this become rotating field winding. Okay, field winding placed in rotor, rotating field. Armature winding placed in rotor, stationary armature. So now we are discussing advantage of rotating. If I rotate field, there is lot of advantage. Instead rotating armature. See, if I rotate armature, what happened? Total weight increases. Lot of drawbacks. Okay, first key point is the total weight on the shaft get reduced. At that point, you write fifth point. Okay, first 4 points, pause the video and then copy down. See, this is coupled to turbine. Turbine rotates. This will also rotate. And this rotating conductors, rotating field, we are giving supply to this field winding. DC supply is required to excite the field windings, because we have to use slip ring and brush assembly. We have to use slip ring and brush assembly. Slip ring and brush assembly. Why we are using this means, whenever we need to give supply to the rotating part, or whenever we want to receive supply from the rotating part, to give supply to rotating part and to receive supply from rotating part, slip rings and brushes assembly plays an important role. Okay, so then finally two field windings or field windings are connected in series. Finally we have 2 points. We have to give DC supply. Okay, you can give AC excitation also, but DC excitation will give constant interaction, rate of change of flux with the stationary conductors. Okay, see, look at here, DC supply is given, but this winding is placed in the rotor. This winding continuously rotates. DC supply available in the outside, that is not moving, it is stationary, supply is stationary. So that supply is given to brushes. Okay, brushes, and the rotating field coils connected to the slip rings. Slip rings will rotate, brushes will not rotate. Brushes will have just contact with the slip ring. Okay, got it? So when supply is given to brushes, brushes receive that supply touches the slip rings. Through the slip rings, current is carrying to the field winding. Whenever current flows the field winding, magnetic field is produced. That magnetic field rotating, rotating field cuts this stationary conductors, and then high voltage is generated. Suppose if I reverse it, if I connected here means, there are three phase winding will be there. Okay, then 3 terminals will be there. Then we have to use 3 slip rings. Okay, three slip ring and brush assembly we have to use if you rotate armature. If you rotate field, then you must use only 2 slip rings are enough. 2 slip ring and brush assembly is enough to rotate field. And to produce magnetic field, whenever current carried by the field winding, to produce the magnetic field, we need an excitation supply. That supply is 110 volts to 220 volt. This much voltage is sufficient to excite the field windings. However, armature, whenever I place the armature in the rotor, it going to develop high voltage. Okay, it is very difficult to receive that high voltage from the rotating part. It is going to generate 11 kilovolts. So what we have slip rings that cannot withstand beyond 1000 volt. Okay, so current manufacturing technologies have a slip rings can withstand up to 1500 volts. Okay, I am not sure about that. You can Google it. Okay, so moreover it won't withstand beyond 1500 volts. But alternator generating 11 kilovolts. If I place here, if the armature winding I place here, armature going to develop 11 kilovolts. I want to collect that 11 kilovolts because it is rotating. For that I need to use slip ring and brush assembly. To collect 11 kilovolts, your slip rings must withstand 11 kilovolts. Then it becomes very complex design. Okay. In order to avoid that, they are placing high voltage winding in the stator and field winding in the rotor. To excite this, how much voltage is required? 110 volts, 210 volts, 220 volts is sufficient. This is one advantage. If I rotate field, how many slip rings required? 2 slip rings. If I rotate armature, you need 3 slip rings. And however, there is a limitation of slip ring can withstand up to 1000 to 1500 volt. Okay. In order to overcome that disadvantage, we are rotating field instead rotating armature. Got it? So now, whatever the voltage induced, this will be the higher voltage. That higher voltage I can easily collect now because it is not running. I can easily collect the higher voltage. I can give this voltage to the external source, external load. Okay, I can transmit this generated voltage to the from generation to customers. I can transmit with the help of the transmission and distribution networks. That will be studying on module 5. So now look at here. First point: large number of conductors and heavy insulation for high voltage required by armature can easily accommodated on the stator. See, armature winding will be very large number of conductors. I can easily accommodate. If it generates higher voltage, I can easily collect it. Okay, that is one of the advantage. First advantage. Second advantage: collecting larger currents at higher voltages is much easier from the stator than from the slip ring and brush assembly on the rotor. See, it is going to develop higher voltage. I can easily collect because it is not running now. Stator it will be stationary, it is not running. I can easily collect. Suppose if I place this winding on the rotor, you must use 3 slip rings, and it is very complex, very difficult. So it is much easier from the stator. From the stator I can easily collect higher voltage. From the rotor side, very difficult. Because it produces higher voltage, your slip rings cannot withstand such higher voltages. That's why we cannot go for rotating armature. Instead, we are rotating field. One is rotating means other winding will be in the stationary side. Okay, got it? So next one is, so suppose this is the outside higher voltage is there in the armature that is connected to some load. The load increases, current in the winding also increases. So then winding will get heated up. So if it is not rotating, we can easily provide ventilation for cooling arrangement. So providing ventilation for cooling the armature conductor is much easier in the stator. Okay, suppose if I place this winding in the rotor, is it possible to provide ventilation in cooling arrangement inside the stator? Is it possible? Rotor will be inside stator. Not possible. It becomes complicated. If it is in the outer side, we can make some holes on the stator frame. We can make some holes. Natural air will pass through that holes and keep the winding in a limited temperature limit. Okay. So that is also possible if I rotate field. Okay, got it? So providing ventilation for cooling the armature conductor is much easier in stator than in rotor. Got it? Fine. Next, mechanical vibrations reduced. If I rotate field, the total weight of the field winding is very less compared to armature winding. So net weight reduces, obviously mechanical vibrations reduces. Okay, so and then less centrifugal force. Okay, and overall, last fifth point, starting only I said it is always better to rotate low moment of inertia. If I rotate field, the net inertia to run the rotor, to move the rotor, smoothly it moves if inertia is less. If inertia is higher, means if I put high 50 kg here, if I put armature winding in the rotor, total weight increases, inertia also increases. Refuse to rotate. Okay, even though this shaft is coupled to turbine shaft, water falls and the turbine runs smoothly. Turbine shaft coupled to this armature shaft of the alternator. Okay, sorry, rotor shaft coupled to turbine shaft. If there is lot of weight on the rotor and less weight on the turbine, water falls, the weight pressure on the turbine cause to rotate, and this weight will be acting opposite to the turbine shaft. Okay, due to that vibrations will occur. In order to avoid mechanical vibrations, we have to rotate field instead rotating armature. So got it, guys? These are all the key points you must remember. Okay, that is the main reason we are going for rotating field construction. Based on rotating field construction, we have two types of alternator. One is called salient pole type alternator, another one is non-salient pole type alternator. I hope, dear students, you got whatever I explained and you understood also. I think so. Okay, guys, in the next video we are going to learn very important one, that is derive EMF equation of an alternator. That is the last theory topic in synchronous generator. After derive the EMF equation is finished, then we are going to do problems on the alternator. By that, module 4 is finished. Okay, remaining 2 to 3 lectures we are going to finish module 4. So please wait, there are some technical issues in our area, so video uploading may get delayed. So I request all my members have some patience. So I will try to finish it as early as possible. So please share our content to your friends. Tell them to become member to our channel. Okay, guys. Have a nice day. Take care. Meet your next lecture. Very easy topic and very easily you can score marks. That is EMF equation of a transformer. Sorry, alternator. Bye bye.